Hi guys, how's it going? It's Joel and welcome back to my YouTube channel. Today we're gonna be reading an article which is kind of different compared with those that we've been reading and which are related with improve our English skills in terms of preparation for the IELTS exam. And because that, today we're gonna be reading an article from the GeeksforGeeks website. In this case, the name of the article is called Turing Machine in TOC, TOC, and it's about kind of related with programming and machine learning, the fundamentals, like the fundamentals of the theory related with machine learning and stuff. So let's go for it. Turing machine in TOC. Turing machine was invented by Alan Turing in 1936, and it's used to accept recursive and enumerable languages generated by type 0 grammar. Turing machines are a fundamental concept in the theory of computation and play an important role in the field of computer science. They were first described by the mathematician and computer scientist Alan Turing in 1936 and provide a mathematical model of a simple abstract computer. In the context of automata, in the context of automata theory, the context of automata theory, and the theory of computation, Turing machines are used to study the properties of algorithms and to determine what problems can and cannot be solved by computers. They provide a way to model the behavior of algorithms and to analyze their computational complexity, which is the amount of time and memory they require to solve a problem. A Turing machine is a finite automaton. A Turing machine is a finite automaton that can read, write, and erase symbols on an infinitely long tape. The tape is divided into squares, and each square contains a symbol. The Turing machine can only read one symbol at a time, and it uses a set of rules, the transition function, to determine its next action based on the current state and the symbol it is reading. The Turing machine's behavior is determined by a finite state machine, which consists of a finite set of states, a transition function that defines the actions to be taken based on the current state and the symbol being read, and the set of start and accept states. Wow, I had a deja vu because I read the same twice, I think. The Turing machine begins in the start state and performs the action specified by the transition function until it reaches an accept or reject state. I didn't like at all this paragraph. So let's go again with this paragraph. The Turing machine's behavior is determined by a finite state machine, which consists of a finite set of states, a transition function that defines the actions to be taken based on the current state and the symbol being read, and a set of start and accept states. The Turing machine begins in the start state and performs the actions specified by the transition function until it reaches an accept or reject state. If it reaches an accept state, if it reaches an accept state, the computation is considered successful. If it reaches a reject state, the computation is considered unsuccessful. Turing machines are an important tool for studying the limits of computation and for understanding the foundations of computer science. They provide a simple yet powerful model of computation that has been widely used in research and has had a profound impact on our understanding of algorithms and computation. A Turing machine consists of a tape of finite length on which read and write operations can be performed. A Turing machine consists of a type of infinite length on which read and write operations can be performed. The tape consists of infinite cells on which each cell either contains input symbol or a special symbol called blank. It also consists of a head pointer which points to cell currently being read, and it can move in both directions. Okay, here we have like a lot of mathematical expressions that are not very important, and the Greek alphabet as well. So because that, it's like I'm gonna give the link to this resource, and I'm gonna put it in the description below, so you can read it by yourself, because it requires some time and patience, and maybe it's better to read it by yourself and lonely, um, so you can try to make it more useful for you, right? Because the mathematical expressions and complex ideas and algorithms, usually you get the idea once you study it by yourself rather than uh, following like a video on internet. Q is a finite set of states. T is a tape alphabet, symbols which can be written on tape. B is blank symbol. Every cell is filled with B except input alphabet initially. What is this letter? Well, basically it's like an M, but pointing to the right direction. Is the input alphabet, symbols which are part of input alphabet. Another symbol is a transition function which maps Q times T, where Q times T times LR, depending on its present state, a present tape alphabet, pointed by the head pointer. It will move to new state, change the tape symbol, may or may not, and move head pointer to either left or right. Q0 is the initial state. F is the set of final states. If any state of F is reached, input string is accepted. Let us construct a Turing machine for L equal 0. How you say this? 0 squeeze and multiply 1 squeeze. Oh, never mind this. I'm not so good even in my native language when it's about mathematical expressions. Q equal Q0, Q1, Q2, Q2, Q3, where Q0 is initial state. T 0, 1, X, Y, B, where B represents blank. Okay, Q3 transition function is given in table 1 as, well, we have like a columns and rows here. Here is a table with all these mathematical expressions, which for sure I'm gonna try later, because otherwise I could get stuck here and I could embarrass myself. Illustration. Let us see how this Turing machine works for 0011. Initially head points to 0, which is on the line, and state is Q0 as. Oh yeah, this, by the way, yeah, that's kinda crazy, because my computer doesn't load the images related with this part of the article. The move will be which means it will remain in the same state and without changing any symbol. It will move to right as. To move will be Q1, 1, which means it will move to Q2 state, and changing 1 to Y, it will move to left as. Working on it in the same way, the machine will reach state Q3 and head will point to B as shown. Using move half, it will stop and accept it. Note: in non-deterministic Turing machine, there can be more than one possible move for a given state and tape symbol, but non-deterministic TM does not add any power. Every non-deterministic TM can be converted into deterministic TM. Is multi-tape Turing machine. There can be more than one tape and corresponding head pointers, but it does not add any power to Turing machine. Every multi-tape TM can be converted into single-tape TM. Question: a single-tape Turing machine M has two states, Q0 and Q1, of which Q0 is the starting state. The tape alphabet of M is brackets 01B, and its input alphabet is bracket 0, 1, close brackets. The symbol B is the blank symbol used to indicate n of an input string. The transition function of m is described in the following table. I cannot see any table because my internet is so bad today. The table is interpreted as illustrated below. The entry Q11R in row Q0 and column 1 signifies that if M is in state Q0 and reads 1 on the current tape square, then it writes 1 on the same tape square, moves its tape head one position to the right, and transition to the state Q1. Which of the following statements is true about M? M does not half of any string in 0 plus 1 plus 2. M does not half on any string in 0, 0 plus 1. 3. M halves on all string ending in 0, 1 ending in a 0. 3. M halves on all string ending in a 0. 4. M halves on all string ending in a 1. Solution. Let us see whatever machine halves on string 1. Initially state will be Q0, head will point to 1 as using Q01, Q11R, it will move to state Q1 and head will move to right as using Q1B, Q0BL, it will move to state Q0 and head will move to left as B1. It will run in the same way again and again and not halt. Option D says M halts on all string ending with 1, but it is not halting for 1. So option D is incorrect. Let us see whatever machine halts on string 0. Initial state will be Q0, head will point to 1 as. Let us see whatever machine halts on string 0. Initial state will be Q0, head will point to 1 as using key 0, 0 equal Q1, 1R, it will move to state Q1 and head will move to right as using. Oh, bro, I cannot barely read this. Are Greek letters, so I'm not too much into the Greek alphabet, so I'm messing up this. It will move to state Q0 and head will move to left as B, 1 head B. It will run in the same way again and again and not halt. Option C says M halts on all string ending with 0, but it is not halting for 0. So option C is incorrect. Option B says that Tm does not halt for any string 0, 0 plus 1 multiply times, but null string is part of 0, 0 plus 1 multiply. And Tm will halt for null string. For null string tape will be using Q0B, halt Tm will halt. As Tm is halting for null, this option is also incorrect. So option A is correct. Get ready to boost. Let's see what is this. Our GATE CS and IT Test Series 2025 offer 60 PIQS quizzes, 60 subject-wise mock tests. Okay, let's go. Blah 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 blah. Personalized insights with students' rankings based on performance and benefit from expert design tests created by industry pros and GATE CS toppers. Plus, don't miss out on these exclusive features. Okay, all in the mock test. Live GATE CSE mentorship classes. Okay, that's it basically. We have like a video about this later. Like once we finish the article, we have like a video of a guy explaining the topic to complement what we read. But yeah, until now this video I know was awful because I barely could like read almost anything. But it is what it is. The point is to try new things and maybe eventually can become like good at mathematics and computer science stuff related with deep topics. It's part of the process, right? Like get out of your comfort zone and try new things and challenging stuff. So as I say, I'm gonna put the source of this article on the description below. So enjoy it. If you find it useful, give me a subscribe and a like, and hit the subscribe button to realize when I upload a new video. And take care, and until the next one. Bye bye.